All right, hi everybody, this is Miss Katz again, and I am going to solve all the problems on the study guide for the Unit 2 Rates, Ratios, and Proportions mid-unit test. So this is a test on just the first half of the unit. The first three problems ask you to define certain terms, and those terms, those definitions can be found on page 3 of your MSG. A rate is a ratio that compares quantities measured in different units. So it's a ratio that compares quantities measured in different units. A unit rate is a special kind of rate in which it's a rate. So it's a comparison of two quantities. In which one of the terms has a value of 0. So for example, miles per hour, apples per pound, those kinds of things. A ratio is just a comparison of two numbers. They're all related. They just get a little bit more specific. So a ratio is a comparison of two numbers. A rate makes it a little more specific that the units on them have to be different. And a unit rate makes it even more specific where one of the values of those ratios needs to be equal to 1. All right, in the second section, we're using the table to answer the questions. It said, what is the ratio of footballs to all balls? So again, in this particular question, okay, we are going to use that table to determine the information that we need. And remember that order matters in writing a ratio. So we need the footballs first. There are 4 footballs. Now it compares that to all the balls in the list. There are 4 here. Another 5, that makes 9, plus 3 is 12, plus 4 makes 16. Now we are not done when we write that ratio because we need to simplify that ratio. And if you look at it more as a fraction and you simplify it by a factor of 4, you'll see that it is 1 to 4. And remember, we can write that 3 different ways: 1 to 4, 1 to 4, or 1 to 4. Any of those are the correct answers for that question. Question number 5 asks us, what is the ratio of basketballs to soccer balls and footballs? This is really important. Soccer balls and footballs are one group, and basketballs are another. The word to is the separator for our ratio. So basketballs, there happens to be 3. And soccer balls and footballs together, there are 5 soccer balls and 4 footballs. Together, that makes 9. Again, we are not done because 3 and 9 share a factor of 3. When I simplify, I get 1 to 3. 1 to 3, 1 to 3, 1 to 3. That means that for every 1 basketball, there are 3 soccer balls and footballs. Now, when we look at the next question, it asks, was the ratio in question 5, that's this one right here, a part-to-part or part-to-whole ratio? Well, basketballs represented one part of the group. Footballs and soccer balls represented another part of the group. So this was a part-to-part relationship. Now, if you look back at question number 4, it was relating the footballs to all of the balls. That is a part-to-whole relationship. And if we would like to show a part-to-part relationship based on this, we are going to write any combination. So part-to-part could be 4 baseballs to 3 basketballs. And that's basketballs and baseballs. You could also write 4 footballs to 5 soccer balls. Any combination that relates one part of the group to another part of the group. A part to whole relationship would be any of the relationships that do one part in relation to the whole? Well, we know that there were 4 baseballs for every, how many balls were in our set when we counted? There were 16. 16 total balls. We could also do how many baseballs and basketballs. Together, that was 7 base and basket to the total 16. If you notice, every one of these part-to-whole relationships will always have 16 total in there, unless you've simplified it. All right, moving on to question number 9. An animal shelter has 18 kittens and 9 puppies available for adoption. What is the ratio of puppies to kittens? And remember, order matters. Puppies come first. So our puppies, there are 9. There are 18 kittens. Even though they were written differently in the descriptor, when I actually sit down to write the ratio, it asks for puppies to kittens. So I have to put it in that order. 9 puppies to 18 kittens. Remember that this can be simplified. 9 goes into both. 9 goes into 9 once. 9 goes into 18 twice. So this ratio is a 1-to-2 ratio, which we can write in 3 different ways. All right, question number 10 states that ECMS spent $105 for 15 pizzas for the Homework Stars party. We want to know what the unit rate, the price per pizza. So I have $105 for 15 pizzas. Okay? Notice dollars to pizzas. I'm going to set this up, and I want to know how much for 1 pizza. Well, how did I get from 15 to 1? I divided by 15. Whatever we do to the bottom of a fraction to keep it equal, we do to the top, and we know that from class. So I'm going to divide by 15 on top. 105 divided by 15. Well, 15 goes into 64 times, so it'll probably be maybe 2 more times than that. So let's try 15 times 7. That's 5, 3. That only gets me to 105. There we go. So we know that this will equal 7. It is $7 for 1 pizza. There's your unit rate, or $7 per pizza. All right, using ratio language is very simple, just a matter of knowing the verbiage to write the following. This means, if there were 4 bananas to 2 apples, it means for every 4 bananas, there are 2 apples. That's what ratio language is. It's just writing out what you know. All right, and the last one on the front side of the page, it says the table below shows the rates of 2 race cars in a race. Evaluate the unit rates to complete the chart. So first we're going to answer question 12 by dividing, because 360 miles in 3 hours, but I want to know how much in 1 hour. So to get from 3 to 1, I divide by 3. Whatever I do on the bottom, I do on the top. And 360 divided by 3 is 120 miles. So it'll be 120 miles per hour. You could write it miles per hour as well, either way. And when we do the yellow car, again, it was 750 miles in 5 hours. We want 1 hour, so we divide by 5. And 5 goes into 750. 5 goes in once. I get 25. 5 goes in 5. Don't forget to bring down the 0. So 5 goes into 0, 0. So it'll be 150 miles per hour. So which car was fastest? Well, the yellow car drove more miles in the same amount of time, so it traveled at a faster rate of speed. Kayla bought 6 candies for $3.60, and Isaac bought 15 candies for $11.25. We want to know how much each student paid per candy. So let's start with Kayla. She spent $3.60. I'm going to bring my decimal up. Remember, we did a lot of this last unit. 6 goes into 36 6 times. Bring down the 0. So it looks like Kayla spent 60 cents per candy. Okay, 60 cents for one candy. That is its unit rate. Let's check on Isaac. So Isaac, on the other hand, he spent $11.25 and he got 15 pieces. Again, we put our decimal up. 15 goes into 112. Well, based on what we did up here somewhere, 7 times that was 105. So I'm thinking that's a good number. And we'll end up with 7. Bring down the 5. And 15 goes into 75 5 times. So he paid 75 cents per candy. And just for fun, she got the better deal. You know us girls. We really know how to shop. Anyway, I hope this helps. And in a few minutes, I'll be posting the video for the other side of the study guide.